This video is on integration using residues. In today's video, we are going to evaluate the integral using residues. In today's video, I am going to evaluate integral 0 to 2 pi d theta by 5 minus 3 cos theta whole square using residue theorem. So as usual, in order to solve this, first I am putting z is equal to e power I theta. Clear? So what is e power I theta? This is nothing but cos theta plus I sin theta. And I'll take modulus on both sides. Modulus of cos theta plus this one is I sin theta. Clear? And mod z value can be written as this is root over this value is cos square theta plus sin square theta. Therefore mod z value is equal to 1. So we got mod z value as 1. So this is the region in which it's a circle with center 0 and radius 1. And the next thing is, in order to keep d theta value, see, I am using this one, z is equal to, see, z is equal to e power I theta. If I derive on both sides, if I make a derivative for this is dz is equal to e, for e power I theta is again e power I theta, I into this is d theta. So dz is equal to zi into d theta. Therefore, so our d theta value will be dz by this value is zi. This value is zi. And the next thing here is we need cos theta value. For cos theta, this value is, cos theta can be written as e power I theta plus e power minus I theta by 2. So cos theta value is equal to z plus this is z inverse by 2. So this can be written as cos theta is equal to this is z plus 1 by z by 2, and therefore cos theta value is equal to this is z square plus 1 by the value here is 2z. 2z. So the value here is 2z. Cos theta is equal to z square plus 1 by this is 2z. And therefore we got the value of d theta cos theta. And now we are going to substitute here, and the region here is mod z is equal to 1, so which is a circle with center 0 and radius 1. And the next one, d theta value is also ready as d theta value is equal to this is dz by z into I. And next one, cos theta value is equal to, so what is the cos theta value? This value is nothing but this is z square plus 1 by this value is 2z. Clear? And now we are going to substitute these values in the integral. So what is the integral here? The integral here is nothing but integral 0 to 2 pi d theta by this is 5 minus 3 cos theta whole square. This is 3 cos theta whole square. Now if I substitute here, this will be integral 0 to 2 pi. In place of d theta, I am writing dz by this is zi by this is 5 minus 3 into cos theta value is nothing but z square plus 1 by this is 2z whole square. So this value is whole square. So this is nothing but integral 0 to 2 pi, this value is dz by zi into, so if I take 2z as LCM, this will be 10z, so this will be 10z. If I send 3 inside, this will be minus 3z square, this is minus 3 whole square. In my next step, this will be integral 0 to 2 pi, this is dz by zi into, see here, this can be written as, if I take minus common, so minus square is again positive, so this will be 3z square minus 10z plus 3 whole square by, so here the square here is 2 square 4 and this is z square. Now I can cancel 1z here and I am sending to the numerator. This will be integral 0 to 2 pi. This value will be 4z by I times of, this value is 3z square minus 10z plus 3 whole square. As you know that, so this can be written as 4 by I times of integral 0 to 2 pi. This value is, here this is dz also, So dz by this value is 3z square. So this is 3z square minus 10z plus 3 whole square. As you can see that integral f of z into dz. From this, what is our f of z value? So f of z value is very clear as this value is 4. Here there is already z here. So there is z here. So this value is 4z by I times of this is 3z square minus 10z plus 3 whole square. As you know that, so if we equate the denominator to 0, so we'll be getting the pole values. So the pole values here, if I equate the denominator to 0, see here, if I equate this denominator to 0, so this will be 3z square minus 10z plus 3 is equal to 0. 3 3s are 9 and this can be written as minus 9z minus z plus 3 is equal to 0. So if I take 3z common, this will be z minus 3. If I take minus common, this will be z minus 3. So z minus 3 into this value is 3z minus 1 is equal to 0. So here z is equal to 3, and if I equate this is z is equal to 1 by 3. So these are the two poles of order 2. So the first pole is z is equal to 3 and the second pole here is z is equal to 1 by 3. So we got two poles here. So first pole here is z is equal to 3 and z is equal to 1 by 3. And as we have the region, so which region we have? Mod z is equal to 1. I'll show you here. The first thing here is mod z is equal to 1. So in this region, so this is the region, and in this region if you observe this one, so which one is inside and which one is outside and which one is on the circle. So this is the circle. So in this circle with center 0 and radius 1, so if this is 1, this will be minus 1. If this 1 is I and this one is minus I. Here 3 will be, so 3 will be here. So this is 2, this is 3. So 3 is outside the given region, that is mod z is equal to 1, and here 1 by 3. So this value is 1 by 3 means 0.33. So 1 by 3 here, it is within the circle. So here out of these poles, so 1 by 3, so 1 by 3 is within the pole and 3 is outside the given region. So this is mod z is equal to 1. Clear? And now we have to find the residue for that. So for finding the residue, I am modifying f of z. So what is f of z here? So just now I have shown here f of z value is, this is 4z. So this value is, I'm showing this is 4z by I times of, this is I times of, this is 3z square minus 10z plus 3 whole square. So this is our f of z. So I'm going to write this as, so I'm going to take 3 common from this. So f of z value will be, this is 4z by I times of, if I take 3 common, this will be 3 square, that is 9. So this is z square minus 10 by 3z plus this value is 3 by 3 whole square. So f of z value is equal to, this value is 4z by 9I into this value is z square minus 10 by 3z plus 1 whole square. Now I'll show you one thing here. The first root here is, the first thing here is, the first pole here is 3 alpha and the next pole here is 1 by 3. So if I add up these two, alpha plus beta, so this will be 3 plus 1 by 3. So alpha plus beta value, if I take 3 LCM, this will be 9 plus 1. Alpha plus beta value is equal to 10 by 3. Clear? And next one, the product here, alpha into beta. So alpha into beta is nothing but 3 into 1 by 3. If I cancel, we got alpha beta value as 1. Clear? Next, the sum of the roots here is 10 by 3. The sum of the roots here is 10 by 3 and the product of the roots here is 1. So here, if you observe this one, I am transforming this 10 by 3 as alpha plus beta. So f of z value, f of z is equal to, this is 4z by 9I times of, this is z square minus alpha plus beta into z plus alpha beta whole square. And see, this will be f of z value. is equal to, this value is 4z by, this is 9I into, this is z square minus z alpha minus z beta plus alpha beta whole square. So f of z is equal to, so this is 4z by 9I times of, if I take z common, this will be z minus alpha. If I take beta common, this will be z minus alpha whole square. So f of z value, is equal to 4z by 9I times of, if I take z minus alpha common, this will be z minus beta whole square. Clear? Whole square. Now this can be written as f of z. So f of z is very clear as, this value is 4z by 9I times of, this is z minus alpha whole square into z minus beta whole square. Now I have to find the residue. So I have to find the residue for the interior pole. Here the interior pole is 1 by 3. Here the beta value, so alpha is equal to, so this is alpha value and this is beta value. Here alpha, the pole alpha is equal to 3 and beta is equal to, this is 1 by 3. So here 1 by 3 is within the circle given region, and therefore we have to find the pole, we have to find the residue at z is equal to beta, and z is equal to beta. As this is a pole of order 2, so this will be 1 by m minus 1 factorial into limit z tends to z naught. This value is d by dz power m minus 1 into, this is z minus z naught power m into f of z. Here our m value here is, the order value here is 2 and z naught value here is beta. Now f of z is also very clear. So if I substitute here, this will become, so this will be the residue value at z is equal to beta will be 1 by 2 minus 1 factorial into limit z tends to beta. This value is d by dz power, this value is 2 minus 1 and this is z minus beta square into f of z. So what is f of z here? This value is 4z by 9I into z minus alpha square into z minus beta square. So if I cancel these two, this will be 2 minus 1 factorial is again 1. So 1 into anything is that thing. Therefore, limit z tends to beta. This is d by dz times of. Here 4 by 9I is a constant thing. So I am writing here 4 by 9I into what remained. So this is z by, this value is z minus alpha whole square. So I have to make a derivative for one time. So this is of the form u by v rule. So this is u by v. So the derivative here is v square v u dash minus u v dash. Now this will be limit z tends to beta. This value is 4 by 9I times of. If I make a derivative, this will be z minus alpha power 4 and this is z minus alpha square. For this, the derivative here is 1 minus z times of, this is z minus alpha. See here, this value will be limit z tends to beta. This is 4 minus 4 by 9I. If I take z minus alpha common, this will be z minus alpha minus 2z by z minus alpha power 4. And if I cancel for one time, so this will be cube. So this is limit z tends to beta. This value is 4 by 9I times of, this is minus alpha minus z by z minus alpha whole cube. So in this I have to keep, in place of z I am keeping beta here. So this value will be 4 by 9I times of, this is minus alpha minus beta by beta minus alpha whole cube. See, this value will be 4 by 9I times of, if I take minus common, this will be alpha plus beta and this is beta minus alpha whole cube. See, if you see here, what is alpha and what is beta? So alpha here is 3. See here, alpha here is 3 and beta value here is 1 by 3. So now alpha plus beta value is very clear. once again as alpha is equal to 3 and beta is equal to 1 by 3. I need alpha plus beta again. So this is 3 plus 1 by 3, alpha plus beta value. If I take 3 LCM, this will be 9 plus 1 and alpha plus beta value is equal to 10 by 3. This is 10 by 3 the value, and beta minus alpha value is, what is beta here? Beta is 1 by 3 minus 3. So beta minus alpha is equal to 1 minus 9 by 3. Beta minus alpha is equal to minus 8 by 3. See, alpha plus beta value is equal to 10 by 3 and beta minus alpha value is minus 8 by 3, minus 8 by 3. So if I substitute here, this will be the residue value at point, at the pole value. Beta is alpha plus beta value. In place of this I am writing 10 by 3 and in place of beta minus alpha I am writing minus 8 by 3 whole cube, minus 8 by 3 whole cube. Now I have to solve this. So for solving this one, so this will be 4 by 9I minus 10 by 3. So if I reciprocal it, so this will be 3 into 3 into 3 and this is 3 for 3 times. So this will be 8 into 8 into 8. See, now I can cancel all these values. So if I cancel all these, so this will be 4 ones and this is 4 twos and again 2 5 times. So this is 9 threes are 27 and this is also 27. So in the numerator minus and minus also got cancelled and this is 5 by, so there is I here and this value is 8 8 is 64. So this is the residue value of f of z at the interior pole. Z is equal to beta. Now we have to apply the residue theorem. So what is our residue theorem? So according to our residue theorem, so we have integral f of z dz is nothing but, so this value is 2 pi I into the sum of the interior poles. So here the interior pole is nothing but beta. Now this is, so what is the integral here? The integral here is nothing but, from the question it is 0 to 2 pi d theta by 5 minus 3 cos theta. Cos theta whole square is equal to 2 pi I times of. So the interior pole here is 5 by 64 into I. So this is 64 into I. If I cancel this I and 2 also 32. So therefore integral 0 to 2 pi d theta by, this is 5 minus 3 cos theta whole square is equal to, this is 5 pi by 32. So this is the final answer. This is the final answer for the given integral 0 to 2 pi d theta by 5 minus 3 cos theta whole square is equal to 5 pi by 32. This is how we have to solve, and let me explain you once again. So this is the question given. So in this question, so we have to take z is equal to e power I theta, and taking modulus on both sides we got the region mod z is equal to 1. So this is a circle with center 0 and radius 1 and we need d theta value. For getting d theta value, I made a derivative on both sides and we got d theta as dz by zi, and again I need cos theta value. So cos theta is equal to e power I theta plus e power minus I theta by 2, and this is how we got cos theta value. After getting all the three values, that is the region, d theta and cos theta value, now this is the integral. So if I substitute all the three values here, and here is the calculation. So after taking LCM and sending to the numerator, and this is our f of z, and if I equate the denominator to 0, I got the two poles as z is equal to 3 and z is equal to 1 by 3. So after getting the poles as alpha is equal to 3 and beta is equal to 1 by 3, so we have to check whether which one is inside or on or outside the pole. So 1 by 3 is inside the given region and 3 is outside the region, and so that we have to calculate the residue value at this point interior pole. So for that f of z is taken, and in this 3 is taken as common, and therefore 10 by 3 can be written as alpha plus beta and 1 can be written as alpha beta. And here after solving this one, so I got f of z ready as this. So f of z value is ready. Now I have to find the residue for the interior pole. Z is equal to beta. So this is the formula. In this, here the order is equal to 2. Order is equal to 2 and the z naught value is equal to beta. After substituting, an f of z value is this one. So I have to make a derivative for one time. So this is of the form u by v rule. So this is v square by v u dash minus u v dash. So after applying that formula and substituting in place of z as beta, and this is the value we got. So sum of the poles is nothing but 10 by 3 and beta minus alpha is minus 8 by 3. So if I substitute everything here and after cancelling, this minus also will get cancelled. So this is minus and this is minus, and after cancelling, so we got 5i into 64. And here now we have to apply residue theorem. The residue theorem is nothing but integral f of z dz is nothing but 2 pi I into sum of the residues of the interior poles. See here, interior pole is nothing but 5 by 64i. So if I cancel, I got the final answer as 5 pi 32. This is how we have to solve. Thank you so much for watching. If you really understand, please go through the playlist. I have uploaded each and every important question, and it will be very helpful for your preparation if you follow all those videos. So you will get a good score, and don't feel that this video is very lengthy, because I have explained each and every step vividly. If you understand, you can solve very clearly. Thank you so much.